All. Am I audible? Anupam Patel, good evening. And Morgan Sharma, Shakshi, very good evening. Am I audible? Please mention in the chat box. Pavan Kumar, good evening. Hello everyone, this is Radhika from pantechelearning. I hope I am audible right now. Please mention in the chat box. Am I audible or not? Very good evening all. Am I audible? I hope I'm audible right now. Please mention in the chat box, am I audible or not? Otherwise, I don't know you receive my voice or yeah, okay. Okay. So welcome back to our day 2 on Power of Electronics Masterclass series. Okay. Thank you. Thank you for the reply. Okay. I welcome you all for engage your learning experience with pantechelearning anytime, anywhere, at any places. We are always supporting to the students in a technical way. And our main vision to help 10 million students easily learn the technology. So today is day 2 on Power Electronics Masterclass. So first of all, I will tell you what is 21 days masterclass. So this is the 21 days industrial learning activity. So it is conducted through live classes on YouTube only. So if you invest just 45 minutes daily to learn the technology from basic to advanced level. So finally you will receive an e-certificate. So how to do the attendance certificate? So to mark your attendance in the YouTube live classes, during the live session, the coordinator will share one Google form link in the chat. So this link only available during the live session only. So also keep in mind the live video will be removed from tomorrow or else 2 days after the classes. So first, today we are going to talk about the introduction on power electronics. So first of all, so this is the agenda for the 21 days. So yesterday we will discuss about these things. And today we are going to enter into the power electronics. So first of all, I am going to ask you one question. What is power electronics? Do you have any idea about this? What is power electronics? Please anyone mention in the chat box, what is power electronics? I am expecting the answer from all of you. What is power electronics? Okay. So power electronics is one kind of the field in electrical engineering that focuses only on converting and controlling the electricity. That means electric power by using some special devices that is called power converters. So these converters, it can help the electricity useful for the different task. It's like you can running a machines or you can providing a lighting or you can charge the batteries by using these power electronic devices. Yeah, exactly, Sasikala. Thank you for the answer, and Shakshi also gave some answers. Yeah, exactly, Venkatesh. That is AC to DC deals with conversion. Okay. So let's get into the power electronics basics, electric power basics. So we know electricity comes to our homes or our office and our factories in a different forms. So for example, in homes, we are getting only the single phase power, while the factories might get 3-phase power. So here the electricity is like a raw power. So we can often needs to be some adjusted for the specific uses. So that is why we need the power conversion. So power electronic, it's all about converting this raw power from one form to the another form. So it's like changing alternating current to the DC current, direct current, and controlling its voltage or a frequency like that. I will tell you real life examples. So these are the real life examples. So if you know the incandescent bulb and electric vehicle. So this incandescent bulb, it can directly use the electricity from the power grid. But the fluorescent lamp, it needs some special device that is called the ballast to work properly. So here the ballast is an example of a power converter. So that is one kind of the power electronic devices, right? So on the other hand, the electric vehicle. So in the electric cars, the power electronics, it helps to control the power from the battery to the motor. So even allowing the motor to send the power back to the battery when braking. So this is what the real life examples of the power electronics. So let's get into some history and evolution. So this power electronics begins in the early 20th century with devices like mercury or rectifiers like that. So later on, they invented some silicon controlled rectifier, that is semiconductor devices. Over the time, the more advanced switches and converters have been developed nowadays. So the first one is we are going to talk about the power converters. So there are 4 main types of power converter. So what does mean by DC to DC converter? So DC to DC converter is nothing but these changes on one type of the DC voltage or a DC current to the another type. So it's nothing but the choppers. We can step up and we can step down the voltage or current by using this DC to DC converter. So it's nothing but the chopper, step up chopper and step down chopper. So the next is AC to DC converter. What is this AC to DC converter? So this is nothing but the rectifier. So these turn AC alternating current from the power grid into the DC. So which is the type of the power that can be used in the batteries? Rectifiers. So the next one is DC to AC converters. So these DC to AC converters, it's called as the inverters. So these take DC from the battery or something like and convert it into the AC. So which is what most household appliances we can use now. So the next one is AC to AC converters. So these changes AC power from one form to the another. It's like adjusting the speed of an AC motor by changing its frequency. So we have seen each converter is composed of fundamental electronic components. What are the fundamental electronic components we have? So we have resistors and capacitors and inductors. So as well as some semiconductors and effectively. So the most important components and effectively. So the most important components is diode, thyristor and transistors. So these are like the building blocks that help us to control the flow of electric power in a different way. So depending on what we need the circuit to do. So the first one is diode. So what is meant by diode? So it's like a one-way street for electricity. So it's electricity, that means current flow in one direction but stops it from going the other direction or other way. So when it is useful, the diode, when it is useful, this is really useful because in many cases we only want the current to move in specific direction. For example, when we need to change alternating current, which changes the direction into the direct current, which flows in one direction. So here the diode helps make that happen. So what is the diode made up of? So this diode is made up of some special materials like a silicon or a germanium. So these materials give the diodes that unique ability to control the flow of electricity. So these diodes are very good at allowing the electric current to pass through them with very little energy loss. That means a low voltage drop. So they also work very quickly, which is a very important in circuits that need to switch on and off rapidly. So at the time we use this diode. And what are the types of diodes we have? So we have a Zener diode and Schottky diode and also silicon controlled rectifier. So what does it mean? So Zener diode in the sense, these diodes are designed to allow the electricity or allow the current to flow the black wire. So but only when a specific voltage is reached. So this is what the Zener diode. So this makes them useful for keeping the voltage in a circuit stable, even if the power supply changes also. So the next diode is Schottky diode. So here you can see this is a Schottky diode. So these Schottky diodes, these have an even lower voltage drop than the regular diodes. So which means they waste the less energy. So they are often used in circuits where efficiency is very much important, like in power supplies for the computers like that. So the next one is SCR. So SCR is nothing but silicon controlled rectifier. So these are the special type of the diodes that can control the large amount of electricity. So they are used in situations where we need to control the high power. So like in motors for electric trains or in some industrial machines like that. So this is what the Zener diode and Schottky diode and also silicon controlled rectifier. So then we move on to the thyristor. So what is mean by thyristor? What is mean by thyristor? Please anyone mention in the chat box. Yeah, thank you all for the responses you gave in live chat. Now only I saw. Thank you. Bharat sir, very good evening. So what is mean by thyristor? Let me know in the comment box what is mean by thyristor. What does it mean? Yeah, exactly. Thyristor is a unidirectional device. Yeah, okay, Shakshi, no problem. Okay, I will tell you. So thyristor is nothing but it's like some advanced switches that can control the large amount of current. So they are very more powerful than the regular diodes and it can handle the much higher voltages and currents. So where it will be used? This makes them very useful in applications of where lot of power needs to be controlled. It's like electric motors, heaters or even in the power grid also. So this thyristor, it has a one control gate that acts as a switch that acts like a switch. When a small control signal is sent to that gate in the sense, the thyristor it turns on and it can allow the electricity to flow through. So once it is on in the sense, it stays on until the current drops to the zero or any another signal turns it to off. So this is what the thyristor. So what are the thyristor we have? Diac and GTO and next one also triac. So diac is nothing but that is the special type of the diode that works in both directions. So here you can see that works in the both directions. So it is used to help the trigger other thyristors or triacs in a circuits. So you will find in diac in things like some light dimmers where they help control the brightness of the light by controlling the power flow. This is what the diac. So the next one is the GTO. So what does mean by the GTO? So unlike the regular thyristors, GTO thyristor, it can be turned off with a control signal. So this gives more control over when the thyristors stop conducting the current or conducting the electricity. So the next one is triac. So the next one is triac. So triac is similar to the thyristor but can control the electricity flow in the both directions. So this makes it very ideal for controlling the AC power, such as the fan speed controls or some dimmers used for the lights. You will find triac in that things. So next one is the transistors. So we have already seen the thyristors and diodes. And now we move on to the transistors. So transistors are a very essential components in power electronics. It acting as a switches or it acting as a amplifiers to control the flow of electrical signals. So there are several types of transistors available, and today we are going to talk about the three transistors. One is BJT, and next one is FET, and next one is IGBT. So what is meant by BJT? So the BJT is nothing but bipolar junction transistor. So this bipolar junction transistor, how it works? It has a three terminals. One is base, another one is collector, another one is emitter. So it controls the flow of current between the collector and emitter by applying the small current to the base. So this is what the BJT. So next one is the FET. So here you can see the FET. So FET is nothing but the field effect transistor. So this field effect transistor also, it has a three terminals. One is a gate and drain and source. So this is an N channel FET and this is a P channel FET. So that they control the flow of current between the drain and source by applying the gate voltage, by applying a voltage to the gate. So these, the most common FET is the MOSFET. So MOSFET is nothing but metal oxide semiconductor field effect transistor. So mostly this MOSFET are widely used because they are very fast and very efficient, easy to control with the voltage rather than the current. That is why it is very popular and also very familiar. So the next one is insulated gate bipolar transistor symbol, and how it works. So this IGBT is a combination of BJT and MOSFET. So it is also has a three terminals, gate and collector and emitter. So the IGBT is controlled by the voltage applied to the gate. It's like a MOSFET, but it can handle the higher currents and higher voltage like a BJT. So this IGBT are used in high power applications such as the motor drives or power supplies and systems that need to control the large amount of power. It's like a renewable energy system, example solar inverters. So this is what the transistors. So we have seen BJT, FET and IGBT. So other than this, we have so many components in power electronics. We have a capacitor and we have inductors and we have transformers and filters. So now we move on to the application of power electronics. So we have already seen the power conversion, that is nothing but rectifiers, inverters, converters. So the next one is wind power generation. So the wind power generation is, in wind power system, the electricity produced by the wind turbine that can vary in voltage and frequency. So we have already known the rectifier converts the variable electricity into the DC power. Then DC to DC converter boosts the DC voltage to keep it steady, even if the wind speed changes also. Finally, this steady DC power then is converted back to the AC to match the grid's voltage. So it can be stored. So a similar process that happens in electric vehicle also. Next one is the motor control system. So these power electronic devices are used in motor control systems like robots and power plants like that. So they help control the speed and force, that means torque of the electric motors, making them run more efficiently. You can saving the energy also. So finally, consumer electronics. This is nothing but the everyday use. So these power electronics are found in devices like computers and smartphones and household appliances. So they help manage the voltage and current to keep these devices running safely and efficiently. So next I will tell you what is the role of power electronics in electric vehicle. Here you can see this is a simple block diagram of the electric vehicle. So these power electronics are very essential block or essential component in electric vehicle because they manage how electrical energy from the battery is delivered to the motor. So they make sure the right amount of power is available in the right form whenever it is needed. So what are the components involved in electric vehicle drive system? So they typically includes a battery pack and power electronic converters. So what does mean power electronic converters? They have inverter and DC to DC converter. So here you can see the onboard charger. So this onboard charger, it receives the AC from the charging plug. That means a power grid station, and that converted to the DC power to this power converter. So next we have inverters also. So next we are going to talk about the characteristics of thyristor in Matlab demo. So I'm going to open the Matlab software here. Okay. So do you have any doubt up to this? So before we enter into the demo session, I will give you the internship details. So you can convert the masterclass into 1 month internship. So particularly internship on power electronics. The actual price is 1,999 and we are offering a 799. So what are the benefits you will get through this internship? In the sense, you will get 30 days recorded sessions. So not only 21 days, you will get the 30 days. But this live sessions only for the 21 days. If you are an internship user, you will get 30 days of recorded content and 30 days of PPT and exclusive simulation files. You can download the simulation files and you will be added to the VIP community group for a doubt and internship updates, and you will get IETE certification confirmation letter, and you will get 90 days of LMS course access, and you will get the assignment and task, and you will get weekly live sessions, and you will get the resume building. You will get the guide from the mentor to create the resume building and mock test, and you will get the internship and participation letter. So this is what the benefits you will get through this internship. Yeah, Mishra, you will get the PPT. If you are an internship user, you will get the PPT and you will get the simulation files also. The actual price for this power electronics internship 1,999 and we are offering a discounted fees just 799. So use this registration link to join as an internship user because this offer will be for a limited period. Only for a limited period. The internship offer ends on 31/8/2024. And we are offering 3-in-1 electric bundle. So that comes under with renewable energy and Matlab, Simulink and power electronics. So these three bundles, the actual price is 2,999 and we are giving the discounted fees. So just 1,199. So this offer also will be ends on 31/8/2024. So what are the benefits you will get? You will get the 90 days recorded sessions, 90 days PPTs and exclusive simulation files. This electric bundle, you will get the 3 big masterclass. One is Matlab Simulink, another one is power electronics and next one is renewable energy source. So you will get 90 simulation files. And also you will be added to VIP community group and IED certification letter and 1 year validity in LMS portal. And you will get the assignment and task and you will get hackathon sessions. You will get the resume building and mock test ideas and you will get 3 internship, not only 1 internship. You will get the 3 internship participation certificate. The actual price is 2,999. We are offering just 1,199 for this electric bundle. So this is all about the internship details. Now I'm go back to the characteristics of thyristor. So now I'm going to create one model here. So for that, I want the thyristor block. So just take the thyristor block. This is my thyristor. And yeah, so this is a thyristor. We have a gate, an anode, and cathode. So I will tell you what is this M. And next, I want the controlled voltage source here. And here we are going to give the pulse. So that is why I want the pulse generator. This is the pulse generator. So next I want the load. So series or LC branch. So just double click on this. I'm going to select the resistor. So press the Control T. So next one, I need the bus selector. I want the bus selector. So what is the purpose of this bus selector? So just double click on this block. You can see. So this block, it accepts the input which can be created from the bus creator. Or else here you can see here in this thyristor block we have a M. So M is nothing but the measurement port. So we can see the voltage and current, that means thyristor voltage and thyristor current from this bus selector. So you have to connect the measurement port to the bus selector. So just double click on this. Just double click on this. Once you've done this connection, you have to connect the measurement port to the bus selector. First you have to delete the signal 1 and signal 2. So I am going to select the thyristor voltage and also the thyristor current. Just click the apply and click the OK button. So now I am going to connect these resistor to the cathode and these minus to the controlled voltage source minus and this plus connected to the anode. So now I want another one block, that is a ramp block. So we are going to give the input of this controlled voltage source. So that is why I am going to pick the ramp block. So next we want to measure the voltage and current. So for that I am going to use the multimeter. So just double click on this workspace area. Just type the block name, that is a multimeter. So this is the multimeter. And now I'm going to connect the pulse generator to the gate pulse, gate of the thyristor. So then we have to connect the scope. So before we are going to connect the scope, I'm going to pick the demux and also the mux. So here, what is the purpose of the demux and mux? And here I'm going to connect this demux to the multimeter. So first you have to select the multimeter. So just double click on this controlled voltage source. So I'm going to give the DC and you have to see the measurement parameter. And I'm going to select the measurement parameter as a voltage. Just click the apply and click OK. Then go to this resistor and I'm going to change this resistor as a 2 and measurement voltage as a branch voltage. Now you are going to click this multimeter. Just a minute. Okay. So now we are going to connect this bus selector and also the mux and demux. So just take the scope. So this is my scope and just double click the scope. Go to this view and select the configuration parameters and number of input ports is a 4. So I'm going to connect 4 input ports. So select the layout, select the 4 layouts and give apply and OK. Okay. So the first one is I'm going to connect this scope. The first one is pulse. I'm going to give the pulse, that is a signal, pulse signal for the gate. So when the thyristor it should be on, when the thyristor it should be off. So I'm going to give the name. So this is my pulse. And the next one is voltage. So here we are going to connect the voltage. So this is the voltage. And next I'm going to connect the current to this mux. And I'm going to connect these current to the mux. So what is the purpose of the demux and mux? So mux is nothing but it accepts the one input and it will give the multiple outputs. And mux is nothing but it accepts the multiple inputs and it will give the single output. So here I am going to adding the two currents. One is the thyristor current, another one is the load current. I am going to add these two current and I will give the two current to the scope. And this one is the thyristor voltage. So this is the thyristor voltage and this is the thyristor current. And I am going to give the name. So this one is the voltage and this is the current. So just double click on the scope. You can see the amplitude and period and pulse width. And I'm going to change the period 2 seconds. Just click apply. Now I want the power guide. So I'm going to change this power guide into discrete mode. And go to this modeling. You have to change some settings. Select this model settings. So select this model settings and go to the solver section. I'm going to select the continuous states and apply and then click OK. Am I audible? Am I audible means please mention in the chat box. Okay, so just double click the multimeter. I'm going to select the first control voltage source and select this one. And next you have to connect the series or a C branch. Yeah, so just click the apply. So this is the way you are going to create your model. So here I am giving the ramp and also here I am connecting the resistor load. Okay. So now I am going to run the simulation. Let's see what will happen. Is it echo? Yeah, just a minute. I will check my connection. Okay, now it's clear. Now I am going to run the simulation. Just click the run button. You will see the output. So first we have to connect the voltage source. So here I am changing the AC to DC. So which means I am using a constant voltage that can slowly increase over the time. So next we have to connect the pulse generator. So this is the pulse generator. So this is like a button that sends a signal, that sends the pulse to turn on the thyristor. So this is what the thyristor block. So this thyristor block, when the pulse is sent, the thyristor switches on and lets the current flow through the circuit. So this is the resistor load. Let's see the output. Yeah, so this is the output. This is the output. So go to this view and select the legend. You can see this is the pulse and voltage, this is the thyristor voltage, and this is the current. So the first graph. So what is this first graph? That one is the pulse. So this it shows a control signal. It shows the pulses that sent to the thyristor. So you can see that pulses are sent at the some specific times. So that is the pulses, it jumps up to 1. That means indicating the on signal. So this one is indicating the on signal, and then drawbacks. This is the 0, that indicating the off signal. So here the thyristor only turns on when it receives the pulse. Let's see, check. So this is the voltage and this is a ramp wave. So this is nothing but DC voltage applied to the circuit. And here you can see this is the thyristor voltage. So this thyristor voltage, initially the thyristor blocks the voltage. So the graph, it shows an increase until the thyristor it gets the first pulse. So this is our first pulse. So when the pulse is received around 2 seconds, the thyristor turns on, the voltage across it drops. Here the voltage drops. So it goes to the 0 because it's conducting the current, it's conducting the electricity. So after turning on, the thyristor voltage, it remains low because it is allowing current to pass through. So that is why it is low. So let's comes to the current waveform. So here we have two currents. So the first current is low. Initially the current is low because the thyristor is off and blocking the most of the current. So once thyristor is turned on by the pulse. So this is the pulse on period. At 2 seconds, the thyristor will be on. So the current start increase gradually as the voltage ramps up. So this one is showing how the current increases over the time as the thyristor that allows the electricity to flow. So this characteristics of thyristor is just a simple characteristics of the thyristor that shows how the thyristor controls the flow of current in response to the pulses and increasing the DC voltage as a ramp waveform. So this is what the introduction about power electronics, and tomorrow we are going to discuss about the rectifiers. So tomorrow we are going to discuss about the rectifiers. That means a half wave rectifier and full wave rectifier, and also what is uncontrolled rectifier, what is controlled rectifier, and what is the main difference between them, like that. So do you have any doubt? So this is all about today's session. Do you have any doubt means please mention in the chat box. Again, I will tell you the internship details. If you want only the power electronics internship, you will get the 30 days recorded content and 30 days presentation and exclusive simulation files. So let's see the agenda. Yeah. So day 3 is simulation of single phase uncontrolled rectifier. So both uncontrolled rectifiers of half wave rectifier and full wave rectifier. And the day 4, single phase controlled half wave rectifier and full wave rectifier. So tomorrow we are going to discuss about the rectifier and what is the main difference between the two rectifiers. One is uncontrolled and controlled. So the day 5, simulation of 3-phase half wave rectifier, both uncontrolled and controlled, and simulation of 3-phase full wave rectifier also. So this is what the basic introduction about power electronics. So do you have any other doubt? I hope this session will be useful. Yeah, Manjunath, definitely we will discuss about the switching frequency in future classes. Okay. So this is all about the today's session, that is a power electronics introduction. So again, I'll tell you, if you want only the power electronics internship, use this registration link because this offer will be ends on soon. The discounted fees is 799. If you want 3-in-1 bundle, so this 3-in-1 bundle, it comes under the renewable energy, Matlab, Simulink, and power electronics. The actual price is 2,999 and we are offering 1,199. So this offer also ends soon. So use this registration link to join as an internship user. Yeah, thank you, Bharat sir. Thank you so much. Yeah, I will tell you the components just a minute. So here I'm using simple thyristor and this one is the controlled voltage source and this is the ramp and this one is the pulse generator and this is the multimeter and this one is the resistive load and this is the bus selector. So these are the D-mux and mux and this one is the scope. So this is all about the today's session. So thank you so much. Thanks to everyone who joined today's session. Thank you all. Thank you also.